So welcome today. My name is Mees Beumer and I'm a spaceflight engineering student. And today I'm going to talk a bit about my master track. For that, I invite you upstairs to go to the 8th floor and then we can have a conversation there. Let's go. Yes, I was lucky enough to get into this selection procedure. There was a selection procedure in place because there's a space limitation at the space flight track. And for that reason, I needed to make a test and an essay for an ethical question. And that way we got into the selection procedure. And at the end, I turned out to be having awarded a place in the space engineering department. I chose my track throughout my bachelor, basically. So I was always planning to do first a bachelor here at the Faculty of Aerospace Engineering, and then do a master's here. And then there was 5 options at my time. So there was multiple to choose from, so to say. And I had always the idea to go for control and simulation because that was something I find very interesting. To control the aircraft and the controllers to interact with pilots. That was sort of thing I was interested in at the time. But throughout the bachelor, I did a lot of space projects as well, and I have a passion for space, so that actually resonated so much that I thought back, oh, maybe it's nice to pursue that path and also go for this track in my master's. And yeah, that is how I came about it. And then I did a design synthesis exercise in space, and I did a committee at the Student Association for Space, and then I rolled right into it. So then the choice was actually, at the end, was not that hard for me. So this track is really, I think, is really nice in the sense that it is relevant in real life. So the courses that are taught and the sort of focus of research is really aimed towards sort of main topics in the space industry nowadays. So we see that there's a focus on miniaturization of space systems. So we have this cube satellite that is first you have satellites the size of school buses, and now we shrink down to milk cartons and even smaller. We have a focus of space debris, tackling with littering in space, and how do we get it out? We have to also be sustainable in space. We have focus on communications of the future and those kind of topics. And courses do sort of renew in that sense and take guest lectures on to talk about what is happening right now, and also to see, hey, where does the theory where does it tie in, and how do you get to a level that you can enter the space industry right away and hit the ground running, so to say. So I knew that I would be challenged at this track. I like a challenge because space is hard and you only have one attempt. But yeah, that's not really a concrete expectation. So in that sense, it was I was a bit open into it. But in the end, I did find really interesting topics. I did find a field in which I want to work later. So that is, for instance, the integration department. So to assemble and test everything and make sure that it works. To make sure that the whole puzzle of the spacecraft actually functions and performs on the first try. So in that sense, yeah, I did find my challenge here. And I did find my sort of next step in my career. So first of all, I did a few. I did actually most of them. So the nicest one is, I think, is the practical and thermal rocket propulsion. So this course is about how rocket engines work and how you calculate the amount of propellant that you need to bring and those kind of things. But that's all very theoretical and spreadsheets and programs. And then in the practical, we actually fire a rocket engine, and that is something that I've never experienced. And then later on, you do not only fire it, but you also compare your calculations with the real life experimental data, and then you see, okay, where does my model go wrong, and where do I need to explain for the discrepancies that exist, and those kind of things. So that is the thermal rocket propulsion practical. And we have also courses like space embedded systems, in which you have to build actually a system that you develop. Depending on your topic, you can also do a lab in microset engineering. So then you help out one of the researchers here at the floor with their miniaturization topic, so to say, and help maybe sort out a control system or a battery system or those kind of things. And we also have this collaborative space project in the collaborative design laboratory. And this is more aimed towards working together and generating concepts in a fairly short time and getting lots of iterations to make this a new space mission basically from the ground up. And that is really together, and you get also workshop in soft skills and how do you work together, how do you do proposal writing and those kind of things. Space embedded systems. It's a course based on knowledge on how computers work and mainly towards spacecraft. An embedded system is something that we as a user don't really use, but which has a vital function. And a satellite, of course, contains many of these systems. And because our spaceflight track has courses that are really interesting, but not really focused towards electronics, Alessandra has drafted this course about space embedded systems to gain this background and to understand how does an operating system work for a computer in space. How do you make sure that it doesn't fail? If we have to reconfigure anything and make use of redundant hardware, how do we go about it? And that is the topic of that course. And then what I really liked about it is that there is this practical in which you make your design. So you first draft your requirements and that whole process. And it's really nice to do a practical like that, because then the details matter. The physics are not gonna sort of get you anything that is not working. If you have to demo it that it's working, you need to make sure it's working. And that's also the spirit a bit that I find in this track. I would say it's the instrumentation, or like space optics, it's now called, course. That is because, not because the physics is really hard, but it's a lot of concepts that I didn't have a background in. So optics is not part of the bachelor program. And then this course does teach you at the master level things about optical design of space telescopes and detectors. But yeah, you have to regain all that knowledge, that prerequisite knowledge, basically. And that's why it was a bit challenging, but also very rewarding, because now I'm in that field and it's really interesting. So I'm even continuing that path. I would advise everybody to find your passion. If you have it, it's very good to listen to, because it will guide you along your way. But more practical is also to talk to people that do various tracks. To see, do my ideas about this track align with the reality, and also think about backup options, because maybe you can do an elective in one track that is something you really want to do, but do the other track as well. For instance, if you want to do something about attitude control of satellites, you could do that in CNS and then do as a still space related topic. So that leaves very nice options. So I would definitely do that. And also, do that beforehand, so to say, and not just when you have to do the selection or when you have to think about a backup option. Backup options are always good, and they might actually be very enjoyable as well. So there are some space topics also distributed among other tracks, and even in the future that might be increasing as well. For instance, rocket engines, they are engines also found that are found in, for instance, flight performance and propulsion, that track, and there are plans to group those courses. Also, there is a space structures department within the ASM track to really focus on, okay, we have space hardware and it needs to be survivable. The rocket launch is the most risky part. How do you go about it? There's some options also in control, the control track. I already mentioned the ADCS, so the attitude determination and control system, and that has a lot to do with control systems, so it also fits there quite well.